This video is about solving a system of nonlinear equations. I have two systems that we're going to solve. Here's the first one. This is a nonlinear system. This is a circle. This is the equation of a circle. And this is the equation of a hyperbola. We could put it in standard form and it might be more recognizable, but this is a circle, and this is a circle, and this is a hyperbola. All right. So let's solve this system and see what could happen. So if we just imagine the possibilities, there's different things that could happen. You could have a circle that's being intersected by a hyperbola and it intersects in 4 places. You could have a circle that's being intersected and it intersects in 2 places. You could have a circle and it not being intersected anywhere. You could also have it not intersecting anywhere, for instance there. You could have it intersecting in 1 place. I think you could even have it intersecting in 3 places. That doesn't look much like a circle, but this just helps you get the idea of the different possibilities. So you could have 0 answers, 1 answer, 2 answers, 4 answers. Those are the possibilities. So this is an instance where we have a circle and a hyperbola. Let's solve this equation. I see a bunch of like terms, x squared and y squared. So how I'm going to solve this one is by elimination. When I add the equations together to eliminate a variable, these are ready to be added because when I add them as is, the y squared will sum to 0. So I get 1x squared plus 2x squared is 3x squared. And this plus 0 is equal to 27. So now I'm going to solve for x. I divide both sides by 3 and I get x squared is equal to 9. I take the square root of both sides and x is equal to plus or minus the square root of 9, or x is equal to plus or minus 3. I get 2 x answers. X is equal to 3 and x is equal to negative 3. Well, once you have an x answer, take the first one, 3, and plug it into any equation that you see. I'm going to choose to plug it into the first equation. So when I put in 3 squared plus y squared is equal to 10 and solve this for y. This is 9 plus y squared is 10. I subtract 9 from both sides and I get y squared is equal to 1. I take the square root of both sides and I get y is equal to plus or minus the square root of 1, which is 1. This right here tells me that when x is 3, I get 2 answers. When x is 3, y can be 1. That's one ordered pair. When x is 3, y can be negative 1. That is a second ordered pair. Or I had another x. I should plug in and see what happens. So if I did that, the same thing basically is going to happen. I'll plug it in again to the first equation. This time I plug in negative 3 squared plus y squared is 10. Negative 3 times negative 3 is a 9. I subtract 9 from both sides and I get y squared is 1. I take the square root of both sides and I get y is equal to plus or minus the square root of 1, or plus or minus 1. This is telling me that when x is negative 3, I get the answer y is 1. And also when x is negative 3, I get the answer negative 1. So I got 1, 2, 3, 4 answers. This is a situation where a circle and a hyperbola are intersecting at 4 points. And these are the points they're intersecting at. All right. Let's look at this other system. Again, this is the equation of a circle. The top equation is the circle, and the bottom equation is a hyperbola. I know that negative 12 over there looks very funny, but if we divided both sides by negative 12, we would have a negative x term, a positive y term, and a positive term over here, and that might look better to us, but that's still the equation of a hyperbola. The y squared would be leading in that case. And so this would be, okay, a hyperbola that faces that way, and maybe a circle. We don't know what's going to happen here. Again, there's the same possibilities of answers, 0, 1, 2, 3, or 4. Okay, these are not ready to be added together because I see like terms, but if I were to add these right now, I would get 3x squared minus 2y squared equals negative 8. And that is okay to do, but it's not helpful because we want to add these in such a way that one of our variables goes to 0. So my choices are to get rid of the x's or get rid of the y's. I'm going to choose to get rid of the y's because it seems a very easy thing to do to multiply the top equation by a 3. And if I do that, I'll have 3x squared plus 3y squared equals 12. And I'll have 3y squared minus 3y squared is 0. So that's what I'm going to do. So I have 3x squared plus 3y squared is equal to 12. That's the first equation. I just copied down the second equation. 2x squared minus 3y squared is negative 12. And when I add these together, I get 5x squared plus a 0 is equal to 0. I'm going to divide both sides by 5. And I get that x squared is equal to 0. So x is equal to the plus or minus the square root of 0, which is plus or minus 0. But this is just a little bit silly because 0 is not positive or negative. 0 doesn't hold a sign, it's just 0. So I only got one answer for my x this time. All right, once you have a value for a variable, you plug it into the remaining. So let's go ahead and do that. I'm going to plug in 0 in for x. I'm just going to choose the top equation because it looks simple. I'm going to choose the equation before I multiplied both sides by 3. So when I plug in 0 for x, I get 0 squared plus y squared is 4. 0 squared is 0 plus y squared is 4. I get y squared is 4, and I take the square root of both sides. Y is equal to plus or minus the square root of 4, which will give me plus or minus 2. This says that when x is 0, I get 2 y answers. When x is 0, y is 2. And when x is 0, y is negative 2. And in this situation, there were 2 points. This circle and this hyperbola intersect in 2 places. And that's it.